Rain, fog, mist, and other forms of precipitation constantly remind us that there is water in the atmosphere around us. This water vapor could have gotten in the air through evaporation from water bodies, transpiration from plants, chemical reactions, or other biological or geological processes. We have a term for the measure of wetness or dryness of the air or of any gas, and that term is humidity. When there's a lot of water vapor in the air, we say it is very humid. If I wanted to know how humid the air around me is, how would I go about it? One way is to calculate the mass of water vapor in a sample of gas and compare it to the total volume of gas in the sample. This is referred to as absolute humidity, measured in grams per cubic meter of air. Another way would be to represent it as a ratio of the current humidity to the maximum possible humidity under the same conditions. This is what is known as relative humidity. Relative humidity is the ratio of the mass of water vapor present in a certain volume of air to the maximum mass of water vapor the same volume of air can hold at the same temperature and pressure. This state when a volume of gas has absorbed the maximum amount of vapor it can hold is what we call saturation. Relative humidity is often represented as a percentage. Now, the amount of water vapor that any volume of air can hold varies with temperature. Hot air can hold a larger amount of water vapor without saturation than cold air. So the same amount of water vapor that will saturate a volume of air and cause a relative humidity of 100% at 15 degrees Celsius might just cause a relative humidity of 20% in the same volume of air at 40 degrees Celsius. Conversely, if water vapor in the air remains the same and temperature drops, relative humidity increases. Relative humidity also varies with pressure. For air at the same temperature, an increase in pressure will increase the relative humidity, as depicted in your image. So why is this important? The human body is sensitive to changes in humidity. At very high relative humidity, often during the raining season, people sweat more easily. And this is because the air around them cannot take any further water vapor. So the moisture from our bodies remains in liquid form on our skin because it cannot evaporate. This leaves a damp and uncomfortable feeling. During the dry season, the humidity is low and the air is dry. As a result, moisture leaves our bodies faster than we can replace it. This usually leads to a dry, itchy feeling in our throats or on our skin or lips. As such, air conditioning standards recommend a relative humidity level of between 30 to 60%. So in modern air conditioners, both the temperature and humidity of a space are regulated for ideal human comfort. Relative humidity is also important in food. Certain levels of wetness or dryness in the production environment can improve a process or make it worse. To make delicious cheese, for example, the relative humidity of the storage unit is advised to be between 75 to 95%. In manufacturing, construction, and the technology industry, humidity is often kept low. And for metals that are prone to rusting, it is often advised to keep relative humidity always below 40%. There are even more applications of humidity all around us in nature and technology. Any ideas? Keep learning to find out more. Bye for now.